Okay, class, today we are going over, today is Tuesday, October 13th, and today we're going to be going over the Unit 2 review, because we have a Unit 2 test tomorrow, okay? So, I'm going to go through each and every single problem to make sure that everyone kind of understands what it is we are doing, alright? So now, 1 through 2, we are trying to solve the equation. If you remember, I have steps to solve the equation. I have 4 of them. Step 1 is distribute. Step 2 is combine like terms. Step 3 is get the variable to one side, and step 4 is to solve using reverse PEMDAS. Alright, so now let's look at number 1. Can I distribute here? Yes, I have a 2 in front of a 6h minus 11, so let's multiply 2 by 6h and 2 by negative 11. Alright, so 2 times 6 is first going to give me 12. Don't forget the h. 2 times 11 is going to give me 22. I have a positive 2 and a negative 11 multiplying by each other, so it will be a minus 22. Then I have a minus 8 equals negative 3h. Okay, so now, what I need to do is I need to I've distributed. Now I need to combine my like terms. Right here, I have 2 different numbers, so I can combine my negative 22 and my negative 8, and that will give me 12h. Negative 22 minus 8 is going to give me negative 30 equals minus 3h. Okay? So, now, I need to get the variable to one side of the equal sign. So what I need to do first is I need to get rid of my smaller of my 2 variables, okay? I have a 12h over here and a minus 3h. 12h on the left, minus 3h on the right. I need to get rid of that minus 3h because it is smaller than my 12. To get rid of it, I need to add 3h to both sides. That will give me 15h minus 30 equals 0. Negative 3h plus 3h will give me 0. Now, I need to solve, which means I need to get this h all by itself, all right? What is preventing first? I need to write that better. All right? So PEMDAS is what I need to do, reverse PEMDAS, okay? I have addition or subtraction and multiplication or division. So first, I need to either add or subtract a number to get my h by itself. I have a minus 30, so I'm going to add 30 to both sides. That'll give me 15h equals 30. Now, I need to multiply or divide. Since this 15h is if it's a 15 in front of my h, I'm going to divide both sides by 15. 30 divided by 15 gives me 2. So my answer is h equals 2. Now I need to do the same thing to number 2. All right? Distribute. 5 times 2b will give me 10b. 5 times negative 20 is going to give, or 5 times negative 4 is going to give me negative 20. Let me write that b a little bit better. All right? Plus 6 equals 4b plus 4. I have 2 terms right here I can combine. So I can get 10b minus negative 20 plus 6 is going to give me negative 14 equals 4b plus 4. Now, I need to get my variable on one side by itself. My smaller is this 4b, so I'm going to subtract it from both sides. Sorry for that overlapping. Let me actually. I'm going to write it over here. So I'm going to have 10b minus 14 equals 4b plus 4 minus 4b minus 4b. What's 10 minus 4? It's going to be 6. B minus 14 equals 4. Let me make that b a little bit better. Again, my apologies. All right, so now I need to get the b by itself. I need to get rid of this 14. I'm going to add 14 to both sides. That will give me 6b equals 18. Divide by 6 on both sides, b equals 3. Okay? I know it's a lot, but you guys have practiced that a few times. So let's move on to solving the inequality, okay? Same rules apply, okay? I need to distribute. Ask if I need to distribute at number 3. No, I'm good. Combine like terms? No, I'm good. I need to get my r to one side of the equal sign. Or in this case, an equality symbol. I have a 7r on one side and an 8r on the other. Which one is the smaller of the two? The 7r. So I need to subtract 7r from both sides. Okay? That will get me 1 less than or equal to 1r plus 6. Cannot write a 6 or b today. All right? So now I need to get the r by itself. To do that, I need to subtract 6 from both sides. That will give me 1 minus 6 is going to give me negative 5 less than or equal to 1r, or negative 5 less than or equal to regular r. And there is my answer. Okay, I moved through that one a little fast. Remember, identify. Which one is the smaller of my two variables? In this case, it was 7r. So I'm going to move that from one side to the other by using the opposite operation. I did that. 8 minus 7 is going to give me 1r plus 6. And then my inequality symbol, 1. I need to get my r by itself, so I need to subtract my 6 from both sides to get my r by itself. 1 minus 6 is going to give me negative 5. And then I'll have 1r by itself. But remember, 1r is the same thing as r by itself. So we don't have to divide right there. We can just erase the 1 and write the r by itself, and that will give me my answer. Now, let's move on to number 4. I have negative 1, 3 plus 4c greater than 5. Okay? I need to distribute. Negative 1 times 3. What's 1 times 3? Is just 3, but it is a negative since I have a negative and a positive. Same thing, 1 times 4 is 4, but it's going to be negative 4c is greater than 5. Okay? I need to use reverse PEMDAS. I need to either add or subtract first. I'm going to be getting rid of this negative 3, so to do that I need to add 3 to both sides. I'm actually going to erase some of this over here. Actually, no, I'm not. I need to keep that there. 6b minus. I'll just do a little so you guys know. All right, so that will give me negative 4c greater than 8. Now, the next step. I have to either multiply or divide. Since I have a number in front of a variable, that means I'm going to divide by negative 4 from both sides. Now, if I divide by a negative number, my inequality symbol is going to change directions. Divide or multiply by a negative number, your sign is going to flip. All right? 8 divided by 4 is 2. 1 is positive, 1 is negative, so C is less than negative 2. All right? Solve the equation for y, okay? This is called a literal equation. We went over this a little bit. So all you need to do is apply the same tactics that we use for solving, but identifying which variable we will be isolating. For most cases, almost all cases in Algebra 1, we're always going to isolate my y. So I need to add or subtract, to start, something that is not with my y. Well, I need to add or subtract my x variable. Okay, so I have a positive 12x. I need to subtract that from both sides. That will give me 6y equals 6 minus 12x. Now I need to get my y by itself, so I need to divide by 6 to each term. That will get me y equals 1 minus 2x. Now what I have to do is I have to flip my 1 and my negative 2x. So I will get y equals negative 2x. This one was positive, so it will be plus 1. Here is my answer for number 5. And you're just going to apply that same tactic to number 6, okay? So I need to add 2x to both sides. Now going to be negative 7y equals 28 plus 2x. Now, I'm going to divide each term by negative 7. That'll give me y by itself equal to, what's 28 divided by 7? 4, but I have one positive, one negative, will be a negative 4. Same thing over here. What's 2 divided by 7? I can't really do that. So what I'm going to do is I'm just going to write it as a fraction, 2 over 7. I had a positive and a negative, so it's going to be negative 2 over 7 x. Now my last step, all I have to do is flip my last term and my first term. So I had negative 2 over 7x. And then I had negative 4, so that's just going to be minus 4. And that is my answer. All right? This is a little confusing. Hopefully it doesn't look that bad from a distance. It does. I'll probably put better notes on Google Classroom once we get to there. But we're going to move on, okay? Now, is it a function? There's an easy way to tell if it's a function. If you see a table or a map or a graph or anything, what you're looking for is for you x values to repeat, okay? So let's go through right here. Let's go through all my x values, okay? I have negative 3, negative 2, negative 1, 0, negative 1. Oh, wait a minute. I already had negative 1 right here and a negative 1 right here, and they both equal different y's. This cannot be my answer. Same thing over here. Negative 3, negative 2, negative 1, 0, negative 1. I have negative 1 and multiple values that go with it. Not a function. Right here. Not only do I have a negative 1 and a negative 1, I have a negative 2, negative 2. Oh, wait. I just have a negative 1 and a negative 1. Never mind. So this one also cannot be a function. Right here, though, I have negative 3, negative 2, negative 1, 0, 1, 2, and 3. All my x values are different, so that means that 7 is indeed a function. All right, so let's move on to the next page. All right? Okay, which of the mapping does not represent a function? That means if I have an x value that goes to multiple y values. if I have multiple domains for my ranges or multiple inputs, or, sorry, scratch that. If I have one domain and multiple ranges, or one input and multiple outputs, that means it's not a function. Right here, 2 goes to 6, 5 goes to 15, 10 goes to 30. That one is a function, so we will not be selecting that. Right here, -2 goes to 7, goes to -2, goes to 1, and goes to 5. That means my x has multiple y's. This is a possibility for my answer. Okay, let's just keep going though. C, 3 goes to -1, 0 goes to 0, -3 also goes to 0, and 6 goes to 2. Now, don't get confused here. Even though my x's went to the same y, that's still okay. This is still a function, so that means that won't be my answer. And lastly, same thing. I have multiple x's going to one y. That is okay. That means it is a function, so that is not what we're looking for. The issue is going to be if I have one x going to multiple y values. That means that it is not a function, so my answer is going to be B. All right? Now, which table represents a function? So let's cross off anytime we see an x multiple times in the table. Okay? 4, 7, 22, 24. Do any of those repeat? Nope, so that could be an answer. Or, okay, so for B, I have 30, 35, 45, 35. Ah, both the 35s repeat, so that means this is not a function. Let's move on to C. 13, 17, 25, 13. 13's repeated. C is not a function. 5, 5, 6, 7. My 5's repeated, not a function. So my only answer choice is A. All right? That's page 2. Let's move on to page 3. Same thing. Which one does not represent a function? So, the only difference right here is going to be graphs. Okay? So, if I have a graph, hold on one second. These are supposed to have arrows on them. Let me make sure I put the right arrows in the right spot. So, remember, on a graph, the way that we can figure that out is called the vertical line test, okay? All right, let me get these arrows in the right spot. They'll have the right spot on yours, but just not on mine right now. Okay, so let's see. -1 goes to... Let me write this right. -1 goes to 3, and 4. 1 goes to 1, and 2. 2 goes to 3, and 4 goes to 3. Okay? So, what we can do for a graph is called the vertical line test. All you have to do there is draw a vertical line at each point and see if that line crosses more than once. For instance, each one of these lines at each one of these points only crosses one point. So this is a function, not what we're looking for. Let's see if my x's repeat. 4, 5, 7, 8. They don't repeat. B is a function, not what we're looking for. Let's look at D. 1, 2, 3, 4, 5. Its x's don't repeat. That means it's a function, not what we're looking for. Now finally, we're going to the mapping. If you look right here, -1 goes to not just 3, but also 4. Same thing with 1. 1 goes to 1, and it goes to 2. 2 x values go to 2 y values, which means that this is not a function, which is what we're looking for. All right, that's it on this page. Let's move on. Okay. Given f of x equals to 11, 6 minus x. Find the value of f of 4. So now, if you notice, I have f of x, and then I have f of 4. What are the difference between the top and the bottom? My x changed to a 4. That is all we are doing in these circumstances. All we're going to do is we're going to take whatever our x is, we're going to take our x and replace it with whatever number this is in here. So for example, the number in there is a 4. I'm going to go and I'm going to change every single x I see to the number 4. I actually need to do what I say. 4 equals 11, 6 minus, I have an x right here, that is going to be 4. And then all you do is just do some math, all right? Solve it. What's 6 minus 4? Well, that's 2. So f of 4 equals 11 times 2. 11 times 2 is what? 11. So f of 4 is equal to 22. That is your answer. That's it. And when we're talking about a table, it's going to ask you to evaluate the function at f of 2. What you need to do is look in your x coordinate and find where 2 is. My 2 is right here. My answer for 2 would be $8. So your answer in this case would be $8. That is how you evaluate a function. Take the x out, plug in the number, and work from there. All right? Here we go. Last page right here. Domain and range. What appears to be the domain of the exponential function graphed on the grid? Ignore what this says. Ignore exponential function. And just focus on what it asks you to do. It says find the domain. Well, we know that domain is x. All right? What we need to have now is we need to have a starting point and a stopping point. Now, when I have x, I'm going to move from left to right and find out where my line or curve starts and stops. So if I follow my line, it starts right here at -1. So my starting point is -1. Now if I follow my line all the way until it has stopped right here, this stops at the point x equals 3. So my stopping point is 3. Now, here's how you decide which direction the mouth for my inequality symbol is going to face. If I look here at -1, if I follow my finger along this line and I look down here at my x's, are they getting bigger or are they getting smaller? It goes from -1, then it goes to 0, then it goes to 1, and then it goes to 2, and then it goes to 3. My x values, when I start at -1 and I keep going, are getting bigger. That means my x is going to be greater than -1. All these numbers starting at -1 are bigger than it. Now, how do we know if we're going to use a line or no line? We have a closed point, which means we will have a line underneath it. Now, if I look at my stopping point, all my x values, when I look at 3, are smaller than 3. I don't have any number where the line is at a number bigger than 3. So that means 3 is going to be greater than x. Now, I have a closed symbol, which means I have a line underneath it. Okay, so my domain is -x less than or equal, or -1 less than or equal to x, and then x is less than or equal to 3. So let's find that right here. There it is right there. You're just looking for the x by itself. Okay? So now, oh, this is a blank page. There's one problem. This is the last page. Now, what are the domain and range of these of the representative quadratic function? Now, my domain starts from the left and goes to the right. Okay, so it starts here at 0. So my domain starts at 0, but if you look on the other end, there's an arrow. So that means my domain is going to go on forever, and it is going to be larger than 0. Now if I look right here, I have an open point, so that means I will not have a line underneath it. All right, so there's my domain. Let's look down here and see if I can find anything that looks like that. All real numbers greater than or equal to. That means this symbol right here. Does that match what we have for my domain? No. So let's cross it off. All real numbers less than or equal to. Do I have an equal to sign? I do not. So let's cross that one off. All real numbers greater than 0 and less than or equal to. There it is. Or equal. We do not have an or equal to. We only have an open point. So then let's look right here. All real numbers greater than 0. That's the only one that matches. So that means my only answer choice could possibly be D. Now if I look at my range, I'm going to explain this real quick. If my range, it stops right here. Stops right there. Now, I don't have a particular number, but what you can do is you can do some guessing, okay? Here's 999.9, and this is 1,000. So, this line is more than halfway. It is not only that, but it is at the middle point between 999.95 and 1,000. So, if I think about that, the number that should be in between right there is 999.975. That's the number that matches right here for my range. Okay? Okay, let's work on these last two, all right? Domain, I need to start from the left, and I'm going to go up to the right. So my starting point right here is, okay, let's count it out. 0, 1, 2, 3, 4, 5, 6, 7. So my domain starts at -7, and it goes up until, if you look right here, this is -1. Okay, and I'll put my x in between. Now, if you don't actively see an open point like you do over here on number 16, that means we are going to automatically assume that we will have a closed point at the domain and the range, starting and stopping points. So, let's see. My x values, if I look right here from -7, are going to do nothing but get bigger from that point. So that means -7, or my x values are bigger than -7. And I'm going to have an equal sign underneath. Now, it is the opposite for -1. All my points on the x-axis get smaller from -1. So that means my sign will be facing away from x. A good rule is just to have your starting point on the left, stopping point on the right, your variable in the middle, x or y. Your start will always be less than, your stop will always be greater than. That's a real easy way to think about it. So if I apply that here to my domain, It starts right here at -1. It ends right here at 5. I'm using range, so it's y. I'll put my inequality symbols where they are at, and then they are close points, so they are equal to. Now, is it a function? All you have to do is draw a vertical line anywhere, and as long as your graph, your line or your curve only intersects once, you're good. Here, it intersects more than once, so that means this is not a function. All right, so let's apply our domain and range to our last question, okay? Here's my starting point for my domain. Here's my ending point. So my starting point is at -4. I have x. My ending point is at 3. All right? Let me write my inequality symbols accordingly. Now, at -4, I have a closed point, so I'll put a line underneath it. But at -3, I do not have a closed point, so that means I will not be putting a line underneath it. That is my domain. Now let's apply our range. All right, there's my starting point. And there's my stopping point. So my starting point was here at -3, and then it went all the way up to +6. And I'll have my y in there since it is range. Let's make sure I put my inequality symbols correctly. Now, at my starting point at -3, do I have an open or closed point? I have a closed point, so it will be a or equal to. At 6, I have an open point, so I'm going to keep that how it is. All right? So now, vertical line test. If you notice, no matter where I draw a vertical line, it is only going to intersect it one time. So that means this is indeed a function. All right, so everyone, that was our review, okay? You can use all these answers. It will be correct on the review. So, a couple things. We have a test tomorrow. If you have questions, please come into office hours. I have them every day, 2:45, 3:30, every day. Or if you can't reach office hours, please email me, all right? So, if you guys have any questions, please shoot me an email, ask me a question. One of those two things, all right? Remember, test tomorrow.